All right, here's 1-3. Still all things linear, but we are turning our attention to what we call mathematical modeling. It's where equations put on really fancy clothes and look really pretty and walk down the runway. It's not true. I made that up. Funny, right? I know. Modeling is where you go from word problems to equations, okay? It's how we take all these properties of functions that we've studied, kind of get this word problem organized and switch it over to the form of an equation, or specifically a function. So we can do some math and some algebra with it to find out some piece of information that we didn't previously know. That's what mathematical modeling is all about. I love it. It's kind of like the point of functions when you get down to it. That's why we study this type of stuff, is to relate it to problems going on in the world and turn those problems or a description of that problem into an equation that we can work with. Okay? Here's just a nice little list to have to look for some keywords, right? If you see sum, the sum of 5 and x, you could go x plus 5 or 5 plus x, doesn't matter. Either one. The difference of 4 and b, difference would mean subtract, right? Here's kind of the key word or key phrase. 8 less than m. So if I had an m, take away 8, and there you go. Percent is typically assigned to multiply, right? 0.03 times t. That would be 3% of whatever t is. Ratio is a good sign to divide. X to 7. And then for an equality, right, here you see the word is, right? The sale price is 10. Well, there's another one, less than L minus 10, right? That took us back to over here where we had less than for subtraction. Okay? Good slide to come back to a little bit, because that's one of the big keys, is to find those keywords to kind of tell you, like, this is giving me some direction as to how I should set this problem up. All right, here's a few descriptors that we'll use to put into equations. Okay, the difference of two natural consecutive numbers. Okay, a little clarification there. Natural numbers are sometimes called the counting numbers, like 1, 2, 3, 4, 5, 6, 7. They're just positive and they're whole numbers. Okay, the difference, okay, would be, there's my natural number. Consecutive means it would have to be x plus 1, or the next one, okay? I don't know what natural number it is, right? I'm just calling it x, but if I was to subtract 2 consecutive, I'd have to subtract x plus 1. Right? There's an is, so I know I've got an equation. Fixed is 500 plus $5.99 per toy to produce. For this last one down here, I feel like you would have to have the hint that distance is rate times time. If you didn't know that, I thought it was kind of a hard one to set up. Once you have that, you're like, okay, the distance is 900. Doesn't say r. Right? It just says that the rate is r miles per hour, and we'd be looking for the time. So there, I've still got two variables, r and t, but that's the way it would be set up. Okay. So one thing right here, you don't have to do this. I'm going to do it on some of these because I think it's a good intermediate step. Before you jump to the equation and variables, you can do what's called writing a verbal model. and then you use that to set up your equation and solve, okay? You accept a job with an annual income of $32,300. Well, I gotta make this smaller so we can see everything. And a year-end bonus of $500. You are paid twice a month. What is your gross pay before taxes? So essentially, just don't worry about taxes for each paycheck. Okay, here is a verbal model. I'm just kind of thinking through each component of this. Like, all right, income is the money I make. Not putting in any of the numbers or anything like that yet. I get 24 times x, right? And as I do this, I'm going to define that variable. That's paycheck amount, and that's what I'm trying to get. Right? Times the paycheck amount plus my bonus. Okay, that's just kind of thinking about how this problem would be structured for getting paid. The money I make is my 24 paychecks plus my bonus. Okay? From there, I can kind of take the equation approach and say, all right, my income is $32,300. My 24 paychecks plus my bonus, which is $500. Okay? Once you've got it as your equation, right? You can see how like the verbal model was kind of my intermediate step. It just becomes an algebra problem. In this case, it will take 2 steps. All right, take out the bonus. I've got $31,800 left over, divided amongst those 24 paychecks. $31,800 divided by 24, 1,325. Okay, there you have it. That is a great example of mathematical modeling. We were just given a description of kind of a scenario. Here's like about the, how much money you're making and how you get paid. What's your paycheck? Okay, we kind of go from that paragraph, work towards an equation. Again, a verbal model might be a nice in-between step for you. Maybe, maybe not. But yeah, try handling it that way. The sum of 2 consecutive natural numbers is 105. What are the 2 numbers? Okay. The sum of 2 consecutive natural numbers. I'm going to start with a verbal model and say, okay, this is saying go pick a number plus whatever number you picked plus 1 has to be 105. Okay? Now, just to make it sense, it's kind of like the verbal model. Really, in a lot of ways, like it'll involve words, but it kind of is the equation, more or less. Because all you're going to see here is I'm going to just basically, for the sake of shorthand notation, is say x is a natural number. It's what I'm looking for. So instead of saying like the number that I'm looking for, I'm just going to say that x plus x plus 1 is 105. And now I've got an equation. Two x plus 1 is 105. Two x equals 104. Divided by 2. It tells me that number I needed to find was 52. So if that's the case, I'm saying the 2 consecutive numbers I'm looking for are 52 and 53. Well, go add those two together, and sure enough, right, 52 and 53 add up to 105, and they are consecutive whole numbers. All right, let's go one that's a little bit more complicated. Not crazy, but a little. Rectangular kitchen is twice as long as it is wide. Twice as long as it is wide. Its perimeter is 84 feet. Find the dimensions of the kitchen. Okay, first things first. L is the length. W is the width. Okay? Now to go to my verbal model, this told me that the length of the kitchen is 2 times the width. Okay? Now if I want to go with my variables, I could say that L, which you can see is right here, there's L, it is 2 times W. L is 2 times W. Okay? Now I got to use this piece about the perimeter, which it said is 84, right? And from what I know about perimeter, it's the distance around the entire two-dimensional space. In this case, it's a rectangular kitchen. So that's length plus width plus width, right? After writing all that, you can start to see why you choose to just define variables, and you're like, well, wait a minute. Why don't you just say, like, L plus L plus W plus W, okay? I'm kind of working my way towards the equation I want to solve, okay? The only problem is right now, my perimeter is defined off of 2 variables, the length and the width. Well, that's not good because I can't solve for both. I can only solve for one. That's where this is going to come in. The length is 2W, so I could focus right here and get rid of those L's and instead say for the first L, 2W. For the second one, same thing, 2W plus W plus W. Divide both sides by 6. And the width of the kitchen is 14 feet. And going back up to here, the length will be 2 times 14, which will be 28. Okay? Another great example of modeling. Right? We just started with that paragraph about here's what's going on with the kitchen, what are the dimensions, and from taking that information and kind of working our way towards an equation to solve, we figured out that that kitchen is 14 feet wide, 28 feet long. You measure a tree's shadow and find that it's 8 meters long. You measure the shadow of a nearby 2-meter lamppost and find that it's 75 centimeters long. How tall is the tree? Okay. Now this one's tricky because it doesn't lend itself to our keywords all that well, right? Because the way to solve this one is to set up a ratio. Okay, but it doesn't use like the words explicitly that, oh, you've got a ratio of these things going on. But we could go this route and say, height of tree divided by its length of shadow. That has got to be equal to, I think they said it's a lamppost, right? Yeah. Over length of shadow. And I'm setting it up as a verbal model. So that's like the approach we need to take to this problem, is those two ratios. They're going to be the same thing, okay? Now, hopefully when I plug in all the stuff I know, it's sufficient to only have a little bit left in order to be able to solve. All right, how tall is the tree, right? I'll just go right up here and say that's going to be X, the height of the tree. The shadow of the tree I know is 8 meters. Over here I need to go 2 for 2. I need both. The height of the lamppost is 2 meters. And its shadow is 75 meters. Now I got to be careful here. I got to move that decimal place twice because I need that in meters, right? Tricky little thing there. That's 75 centimeters. Is 0.75 meters. Now I've got the ratio set up. I'd say 2 divided by 0.75. Right? If I multiply this side by 8, multiply that side by 8, X is all by itself. Let's see here, get that out of there. Times 8. Let me see, it is a pretty big tree. 21.3 meters, right? That's coming from 2 over 0.75 times 8. That's just a calculator piece. Just throw that in. And you get a little over 21 meters. Okay? That's all for 1-3. As always, if you run into any questions on the homework assignment, make sure to let me know. Get in contact with me and give me those questions, and we'll address those if they come up.